This last video is just a video to give you some extra practice. So I'm not going to go through this too slowly. I'm going to go through this pretty quickly, mostly so you can just see my thought process and listen to my thought process and see the answers so you can check your answers. I would definitely recommend going through this whole worksheet, the whole worksheet on 3H, doing as much of this as you can before continuing on with this video, okay? Just watching is not going to be very useful. Try it, struggle with it, work through it, ask questions, and watch the video. As a reminder, we also do have this page right before that just summarizes kind of all the formulas and definitions that we introduced in this unit. This is good for reference. We're not going to be going through this in the video though. So we got 3 examples for you with a bunch of different parts. There's a random survey of autos, cars, parked in student and staff lots at a large university, and they're classified by brands and origin as seen in the table. We got another contingency table right here. This time, we actually don't have the totals. Actually might be useful to find these, okay? You don't have to, but it's probably going to be helpful. We add all of these up, 88, 195, 117, 164. Now let's make sure these two totals add up to the same thing. 257, 359, and then adding these is 359 as well. Okay. So what's the probability a car is driven by a student and the car is American made? So driven by a student is these ones. American made is this one. There's 107 out of 359. And check to see whether that reduces or type it into a calculator. I'm not going to for this one. What's the probability the car is Asian made or driven by a staff member? Asian made, driven by a staff. There's 102 that are Asian made. There's 164 driven by staff. And there's 47 that are both. Oh, dang it. I forgot to erase these circles. I don't want these circles staying up forever. All right, so we can do this. And again, there are 359 total. We'll use this to get our answer. Add it all up and see what you get. For C, what's the probability that a car driven by a student is American made? So we're only looking at these ones now. Ignore everything over here. We're only looking at the cars driven by students. This is conditional probability. What's the probability that, assuming we know a student drives it, it's American made? 107 out of 195. All right. And again, simplify your answers where possible. What's the probability a car is not European made? That's just going to be 1 minus the probability that it is European made. European made, there are 45 of them out of 359. And again, you could find that out. Given something's driven by a staff member, what's the probability it's Asian made? Conditional probability. Again, we only look at the ones driven by staff. 47 out of 164. Is the origin independent of the type of driver? Well, if it is, then the probability that it's a student, the probability of a randomly selected car being a student's should equal the probability that it's a student's given some kind of brand. Well, no, American. And we can check these. Probability that something is a student's. That's going to be 195 over 359. Is that the same as looking only at American cars? and looking whether a student drives it. That's 107 over 212. If these are the same, it's independent. And again, you can pick a bunch of different pairs. You didn't have to choose student and American. You could choose other pairs. So we'll just type it into our calculator and check these out. 195 over 359. That's about 0.5432. That's a nice number. And the other one's 107 over 212. That's 0.5047. Again, they're kind of close, so they're like almost independent, but they're not the same. And in Unit 8, we talk more about how close is close enough. But here, we're going to say no. That's the first example. And again, when I said I'm going through them quick, this is kind of what I meant, just to give you an idea on how to start them, see whether you're doing them correctly. Again, try this next example if you haven't already, before continuing on with the variable. So let's say we have got some casino chips, or maybe tortilla chips, I don't know, some kind of chips, maybe Doritos, who knows? Some kind of chips, 3 black, 4 red, 2 white, and a green. What's the probability of drawing a black chip? Well, there's 3 blacks, there's 10 total. Probability of a black one is 3/10. White or green, there's 3 that are white or green, also 3/10. What's the probability of drawing 3 red chips with replacement? That means they're independent. So this is the probability of red, and then red, and then red, and they're independent, so we can multiply them together. Multiplication, and means multiplication. We don't have to worry about conditional probabilities because they're independent. Well, a red chip, that's 4 out of 10. Multiplied by each other 3 times, so we cube it. And what you're going to get is 64 out of 1,000, which is 6.4%. So even though there's quite a few reds, it's pretty unlikely we draw 3, even if we put them back. What's the probability of drawing 3 red chips if they're removed every time? Should be smaller. So they're not independent anymore. So again, the probability of red and then red and then red. The probability that the first one's red times the probability the second one's red, assuming the first one was already red, times the probability the third one's red, assuming the first 2 were red. So the first one being red is 4/10. But we didn't put it back. So the second one, there's only 3 red ones left. There's only 9 total. And then the third one, there's only 2 reds left. And there's only 8 total. We get 24 as our numerator, 4 times 3 times 2, divided by 720, which is 1 over 30. Okay. Which is 0.03 repeating, or 3.3% repeating. I got my math right? But pretty unlikely. Less than half, or about half the chance, as if we put them back. Another example, 56% of all American workers have workplace retirement plan. 68% have health insurance, and 49% have both benefits. Okay, so 56% is one, 68% is the other, 49% is both. We're going to select an American worker at random. What's the probability they have a retirement plan and health insurance? So again, this is going to be retirement. This is going to have health insurance. And 49 is retirement and health insurance. So 49%, that's it. Okay. 49%. What's the probability that they have one or the other? Now be careful. I don't like, I wrote 56%. Can't just add them together. This is where we really have to use that formula. These are not mutually exclusive. In fact, a lot of people will have both. The probability of retirement or health insurance is the probability of retirement plus the probability of health insurance minus the probability of both. Retirement was 56%, health insurance was 68%, and both was 49%. If you do that, you should get 19 plus 56, just 75%. So 75% have one, the other, or both. See, what's the probability they have health insurance, assuming they have a retirement plan? Again, we're going to need this formula. Probability of health insurance, assuming they have retirement. The formula we have for conditional probability says this is the probability of both divided by the probability of the second. Well, we know 49% have both, and we know that 56% have retirement. Type that into a calculator. You get 49 over 56. Oh, which is actually a really nice number. 87.5%. Okay. Given that they have health insurance, okay. Remember, given is what's after the vertical bar. What's the probability that they also have a retirement plan? So very similar, just kind of switched in different language. So the numerators, probability of R and H, which is the same 49% as before. The denominator now is just the probability of H instead. So this is still 49%. Healthcare was 68%. And we can find this out again with a calculator. 49 over 68 is going to, this one is approximate, so we'll use the wavy equal signs. 72.06%. And lastly, we are asked, is having health insurance and a retirement plan independent? Well, if they were, right, they're independent if the probability, there's actually two definitions. Probability of health given retirement equals probability of health. Another definition that you can use that we had earlier is the probability of both being their product. Health and retirement equals probability of health times probability of retirement. I think the second way is actually probably a little easier for a lot of students to think about it. Two ways of checking independence, this way and this way. Okay? And if you use the definition of conditional probability, use this guy over here, you can see that they really are the same definition. I think it's maybe a little easier to find it the second way. This was 49%. Health insurance was 68%. Retirement was 56%. Are these equal to each other? Well, the right-hand side is 68 times 56. That's 38.08%. So, no, these are not equal. They're not equal. That means they're not independent. Not even close. All right. They're independent if these things are equal to each other. One will affect the other. Okay. If you know someone has health insurance, it's more likely that they have a retirement plan, and vice versa. Are having these two benefits disjoint? Disjoint means, can they both happen at the same time or not? If they can't happen at the same time, they're disjoint. Well, we know that it's possible, right, to have both a health care and a retirement plan. It was 49%, right? I'm not making, yeah, good. I'm not making that up. They're disjoint if the overlap is 0. Yeah, it's possible. So no, they're not disjoint. It's possible to have both. And in fact, more likely to have both. I mean, if you have one, it's more likely that you have the other. There we go. And that's just a quick review. Again, I didn't take very much time with these, but it should be a good practice. Let you check your answers, give you some more information, and you can use this as a way to ask me questions as well. Okay. So look over, if any of these explanations didn't make sense to you, that's a perfect thing that you can ask me. Okay. Send me an email, show up to student hours, ask whenever. Okay. Good luck. Hope you enjoyed categorical data and probability, and I'll see you next time.